Here there is a version of the bubble sort algorithm. We have parameters, integer, pointer, and list. And list is the array containing the items to be sorted. And integer n is the second parameter and is showing the size of the array and list. There is no return value here. In the algorithm, we have two for loops. In the first for loop, we have parameter pass, which is initialized with n-1. The loop continues while the pass is larger than 0. In each term, the value of the pass is decremented by 1. In the inner loop, we have another variable I starting with 0. It continues while I is less than pass. Each time I is incremented. In this inner loop, for each value of I starting with 0, we are comparing the items stored at position I and I plus 1. If the item at the location I is greater than the item stored in the next location, then we are swapping the content of location I and I plus 1. So we are calling the swap function with the items at location I and I plus 1, and in return these items are swapped. After this inner loop is completed, then we print the content of the array by calling the function print. And this is repeated for each pass starting from n-1 and while pass is greater than 0, and it is completed when the value of the pass becomes 0. It is required to write the output printed at each pass for the initial value of the n list given as here. Now we are starting with the initial value of the array as given in the example, and each pass we are trying to find out what is the content of the array to be printed. For each pass, we will move left to right, swapping adjacent elements as needed. Each pass moves the next largest element into its final positions, and these are going to be shown in yellow. We are starting to pass 0, and we are comparing the first two items. The first pair of items in the correct order, so there is no swap operation. Go to the next location and compare these two. Their order is not correct, they are to be swapped. And go to the next location, they are to be swapped. Go to the next location, they are in the correct order, so there is no swap operation. Go to the next location, swap is needed. And next location, swap is needed. Go to the next location, swap is needed. And for the last pair, they are in the correct order. So the largest element is in the correct position now. This is the end of the first pass, and what we will see at the output device is the content of the array as given here. At the output we will see 14, 43, 27, etc. up to 70. And then we are going to the next pass. The value of the pass is incremented by 1, it becomes 1. And we are starting with the location 0. We are comparing these two. They are in the correct order. There is no swap operation. And go to the next location, compare these two, and there will be a swap operation. Continue with the next pair. There is no swap operation. And with the next pair, there is a swap. Go to the next location. There is a swap operation. And increment I, another swap is needed. Go to the next location, and these two are in the correct order. So this is the end of pass numbered as 1, and 57 is in the correct location now. We continue with the next pass. Again, starting with the location 0, compare these two, and there is no swap. Go to the next location, there is no swap. increment I by 1. Now swap is needed. Go to the next two, there is no swap, and now in this pair the order is not correct, and swap them. Go to the next location, they are in the correct order. Now this is the end of the third pass. We have the third largest value in this position, and whatever the content of the array is now will be sent to the output device. We continue with the next pass. The value of pass is 3 now, and again we are starting with the location 0. Compare this to, there is no swap. Compare this to, there is no swap. Compare this to, there is no swap. And then if we compare this to, then they are swapped. Go to the next pair, they are in the correct order. And this is the end of the pass numbered as 3. And 45 is the fourth largest value in the array, and it is now in the correct position. Now we continue with the pass value as 4. We are starting with the first two elements in the array. Compare them. They are not swapped. The next two not swapped. And these are to be swapped now. Go to the next location. They are in the correct order. So this is the fifth element in the correct position. This is the end of the pass 4. And at the output, we will see all these items as given here. We are starting the pass 5. Again, compare the first two elements. Go to the next location. Now swap is needed. Go to the next location. There is no swap. Now 41 is in the correct position. Continue with the pass 6 and compare these two. They are in the correct order, and these are in the correct order. Now 27 is in the correct location. In fact, because there is no swap operation in this pass, we could stop the algorithm. However, for the code given, we continue with the next pass. This is pass 7. We compare these two. They are in the correct order. The next largest element is 21. It is in the correct location. So this is the end of the bubble sort, because we have a single element now in the array, and it is in the correct position. At the end, we have the content of the array as given here, and notice that all the items are in the correct order. The items are sorted. The solution is provided here. The first line is corresponding to the initial content of the array. Then for each pass, whatever the content of the array is provided here.